সবাই স্ক্রিন দেখতে পাচ্ছো, তাই তো?
হ্যাঁ স্যার, দেখতে পাচ্ছি।
ওকে। Non-sinusoidal wave analysis. Now, up to this discussions, we are restricted on sinusoidal wave analysis. Now, most of the cases, as an electrical engineer, you will find that most of the waveform is non-sinusoidal nature. They are very much close to sinusoid, but not exactly identical to the sinusoidal waveform. So most of the cases, in practical cases, all of you face this sort of waveform, which are closely looks like a sinusoidal wave, but it is not exactly sinusoidal wave. That is, they are basically called the non-sinusoidal wave. Now, in this slide, it is showing a waveform, but you can easily identify that this waveform is not looks like a pure sinusoid. Now, if it is not a pure sinusoid, so definitely we have a questions in our mind how this waveform or what are the component of the waveform present. So suppose if a particular, say, component or device that is basically called the splitter. Splitter is just you think about a device which can predict what are the combinations or how this waveform is basically uh, created, or what are the component or what are the other waveform presence in this particular waveform. So this is a type of device that is we are basically called the splitter. With the help of the splitter, if we find out what are the component present inside this particular waveform, say first we'll see this waveform is basically consist of two waveform. One is it looks like a pure sinusoidal, and this is also looks like a pure sinusoidal. So basically this waveform, this non-sinusoidal waveform is basically consist of two sinusoidal waveform. But what is the difference between these two sinusoid? Difference between these two sinusoid is their frequency is different. Means they are completing one cycle at different time. So if I analyze or if I find out what are the components present inside this particular non-sinusoidal waveform with the help of a certain device, namely we are called splitter, that we'll find that that is basically consist of two sinusoidal waveform. One is having higher frequency and another is lower frequency. Okay. Now, similarly, if you add this two waveform, say by using another circuit that is basically called the adder, so definitely we will get that this waveform. Now you see, if I add these two waveform, what we'll get up by splitting this actual waveform, now definitely will be get that original waveform. So we can say with the addition of these two waveform, ultimately we will get that resultant waveform which is looks like a non-sinusoidal waveform. Now you see, if you just add here, this is 0, so that is why this portion is 0. Now this is negative, but here this is positive, so somewhat that summation of this negative and this positive ultimately we will get some positive value, but it is not actually follows that any one of the sinusoidal waveform. So in that way, here if you find out the sum, in this instant these two are positive, So summation of these two is basically more positive value. So in that way, we can find out that what is the
ও আচ্ছা স্যার না আমি
and
আপনার সাথে সকালে কথা হলো ওই হ্যাঁ লায়ন্স ক্লাব থেকে
any
আমাকে ফোন করেছিলেন উনি
excuse me, please mute all of you. When I am delivering lecture, during that time you have to mute all, and you have any questions, then you can ask me freely. Just unmute yourself and then ask the question. Okay. Now after addition of these two waveform, we will get that original non-sinusoidal waveform. So basically we can see also. I want to show you another waveform. Now this is again, this is not a pure sinusoidal waveform. This is a non-sinusoidal waveform. With the help of splitter, if I split this waveform, now we will find that this waveform is basically consist of three sinusoidal waveform having different frequency. Okay. Similarly, if you add these three waveform, so ultimately, originally you'll be get back this waveform. So this is basically the. So what we found from these two waveform, if you split this waveform, or if you want to, if you by any means, if you extract what are the basic component present in a particular waveform, now they are basically represented as, they are basically the combination of sinusoidal waveform. Okay, so that's, I want to show you that a particular non-sinusoidal waveform is basically consist of a set of sinusoidal component. Okay, so this is basically we wanted to know. So what are the component which is basically present, or what type of sinusoidal component is basically present in a particular non-sinusoidal waveform. This is our object to find out this. Okay. Now, in your say class note, if you see, always as an electrical engineer, always our object to generate a pure sinusoidal waveform. Pure sinusoidal waveform is, say, that is output of the alternating generator. We want to get this should be a pure sinusoidal voltage waveform. But in practical cases, what will happen, this waveform is not a identical sinusoidal waveform. They may be deviate lesser or greater from the actual waveform. So suppose in this example, if you see, we are basically supplying a sinusoidal voltage waveform with transformer. Now if I measure the current, now you see that current waveform is basically a non-sinusoidal waveform. Okay. So this is basically the voltage, and this is basically pure voltage, pure sinusoidal voltage, which are applied or which are basically provide a supply to the transformer. But if I measure the current, that current is non-sinusoidal. Similarly, this is the three-phase winding of an alternator. If I measure the output voltage waveform, always our target, this waveform should be a sinusoidal waveform. Okay, but exactly we got that waveform is basically some ripple is present, which we can say this is closely to the sinusoidal waveform, but it deviates a little bit or slightly from the actual one. Okay, so frequently we have to face this sort of non-sinusoidal waveform in our practical cases. So we have to know what are the component is basically present in this non-sinusoidal waveform. This is our object. Okay. So, okay, just to consider that slide. So first, this type of waveform is first observed by Daniel Bernoulli in the year 1782. But this scientist is basically find this mathematical formula for solving certain problem relating to vibrating strings. But systematic study of this subject was, however, that will be proposed by Jacques Fourier in 1768 to 1830. What he suggests? He suggests that a particular waveform, non-sinusoidal waveform, we can represent it, that non-sinusoidal waveform, by a number of sine wave having different frequency. So this is the observations of the Fourier. So if this is the function of the non-sinusoidal wave, so non-sinusoidal wave can be represented by a number of sine wave of different frequency. This is the observations. Okay. So any non-sinusoidal waveform can be represented by a set of pure sinusoidal waveform, but having different frequency. One of the term may be the DC component, but most of the cases we found that this is basically combinations of pure sinusoidal waveform having different frequency. This is the observations of the Fourier. So most non-sinusoidal wave found in electrical engineering can be expressed in terms of sine wave component of different frequency by means of Fourier series. Each sine component may be handled according to the laws governing by the calculation. Now, the mathematician Fourier proposed how to calculate this sinusoidal waveform, that a particular non-sinusoidal waveform consists of what percentage of sinusoidal waveform. So we have to know, we wanted to know that what are the component of the sinusoidal component of different frequency present in a particular non-sinusoidal waveform. So he proposed certain mathematical formula for deriving this, that is basically called the Fourier series. So according to the Euler's formula, Fourier series of function theta, here you keep concentrated on this. There, in this portion, there is a little bit mathematics are involved, but you have to learn this mathematics. These are, I try to represent this mathematical formulae in the simplified manner, but again, you have to study this, because most of the cases, 80% of the total electrical engineering problem is basically based upon this. Okay. So without knowing this, we can't proceed for the different analysis of electrical problem. So you have to study these things very carefully and in concentrated manner, so that we can estimate it, or we can remember what are the problem or what are the formula. Today we are going to learn that you have to remember. So this formula is basically required frequently. Now what is our target? Any non-sinusoidal waveform according to the Fourier formula that can be represented by a set of sinusoidal component, that is the sine component, and set of non-sinusoidal, set of cosine component. Just I show you that this is basically the combinations of sine component and combination of cosine component, and one DC portions also present. So what is our target here? Our target is to measure A0, and we want to find out what is the coefficient A0, A1, B1, A2, B2, like that. Okay. So this theory, say suppose here, if you notice that here A0 is represented by this formula. AN means if you replace n by 1, so you can get the value of A1. If you replace the n by n equals to 2, you will be get the formula of A2. In that way, it may be consist of n number of series. Just this is a general formula. So this is the formula of finding that coefficient A, and A means an except A0, and this is basically the formula for finding Bn. Okay. Now, in your mind, how you will write this theory? Okay, I will discuss how we will get this formula of A0, An, and Bn. But you have to remember this general expressions. This is very simple. That is basically consist of set of sinusoidal and component, and one DC component is there, like A0 plus A1 sine theta plus B1 cos theta plus A2 sine 2 theta plus B2 sine 2 theta, in that way. So mathematically it is right in that way. You can write that is one DC component present, that is A0, and summation of An sine n theta means this is basically we consider that altogether A1 sine theta, A2 sine 2 theta, A3 sine 3 theta, in that way. And this is basically represents that altogether B1 cos theta, B2 cos 2 theta, like that. Okay. Now what is our target? How we'll get this formula? Okay. Just one by one, we want to find out the coefficient A0, An, Bn in that form. Now, before going to discuss how to find out this coefficient A0, A1, and A0, An, and Bn, but you have to remember this basic formula of integral. Those who are studied or completed 12th standard, they will know that these are the general integral formula. But those who have not studied that 12th standard, but they have to either they have to remember this, or they have to, again, I think in mathematics portion uh, they will cover that integral portions in either diploma level or UG level. But you have to remember this common general formula, which is frequently required for the solution of this type of problem. What is the first formula? That is, if you integrate cos n theta d theta within the interval, say alpha to alpha plus 2 pi, we are considering a particular instant that is basically from alpha to alpha plus 2 pi. If you find out that is the interval is 2 pi, alpha plus 2 pi minus alpha. So we are basically integrating cos n theta d theta with respect to this limit alpha to alpha plus 2 pi, and ultimately what is the cos n theta integration sin n theta by n. This is the general thing. This is not scope of in my class to discuss that how will we get that integration formula, but you have to remember, if you integrate that cos n theta d theta, that will be sin n theta by n. If you put the limit, ultimately that value is equals to 0. Similarly, integration of sin n theta d theta, that is also equals to 0. Now we want to find out that integration of this function, that is cos m theta cos n theta. So cos m theta cos n theta, if you consider that as by half into 2, so that can be represented by cos m plus n theta plus cos m minus n theta. Now if you take integrate and put that value, limit value, so ultimately that value also equals to 0. Just you have to remember this general formula. There are some other general formula also there. This is now if I want to find out that integration of cos square n theta d theta. So cos square n theta d theta, similarly you have to find, you have to consider that as a half into 2 cos square n theta d theta. Now you know the formula of 2 cos square n theta. If you put that value, ultimately you will be get that integration of cos square n theta is equals to pi. This is a non-zero value. Similarly, sin m theta sin n theta d theta integration value is 0. But here this is mixture of sine and cosine, sine m theta cos theta. So for that case also you will be find that this is 0. Similarly, if it is consist of sine n theta cos n theta, for that case this is also 0. But cos square n theta d theta will find that this is pi. Similarly, sine square n theta d theta, also this value is equals to pi. Now with remembering this general formula, now we want to find out that a0 from the basic function, we are considering that basic function f theta. Now what is our target? We want to integrate this f theta function d theta in the interval alpha to alpha plus 2i pi. So for finding a0, so you have to take find out the integration of f theta d theta within this interval alpha to alpha plus 2 pi. So there are three components, DC component. Why we are considering DC? Because there will be no such frequency term is present. This is a constant value. So a0 d theta, we have to integrate alpha to alpha plus 2 pi, and summation of n1 to infinity an sine n theta d theta. This is the integration, and this is the integration of alpha plus 2 pi bn cos n theta d theta. Now you see, if you remember the general formula of what? This is the general formula. If you take integration of cos n theta d theta, that is equals to 0. If you consider that sin n theta d theta, that value is equals to 0. Now, by considering this or remembering this general formula, here you see this is basically the integration of what? Integration of sin n theta d theta. So what is the value of this? That value is equals to 0. Similarly, this is basically the integration of cos n theta d theta. What is the basic value according to the general formula? That is basically 0. So that is why we write this integration of these two terms is equals to 0. But you have to consider that integration of a0 d theta, this is a constant value. So ultimately you will be get what? Ultimately you will be get theta as an integration value. Now if you put that value limit, integration limit in this value, so that should be equals to alpha plus 2 pi minus alpha. So ultimately you will be get that this is basically a0 into 2i pi. So ultimately what we will get? a0 into 2i pi, which is equals to alpha plus 2 pi f theta d theta. Now just we want to find out what? We want to find out a0, then you replace that 1 by 2i pi here. So ultimately that is looks like a0 is equals to 1 by 2i pi alpha to alpha plus 2i pi f theta d theta. So this is the equations, or this is the formula for finding the a0 for any waveform. If you know that function value, so from that we can predict that what is the value of a0 by integrating that function within the limit alpha to alpha plus 2 pi, and that is 1 by 2 pi of this integration is basically provides that a0 value. Okay. Now, what is our target? Now, our target is to find out an. So, for finding an, just we have to consider that general formula of f theta. Now, we have to multiply that f theta by some other term, that is the sin n theta. In both the side, we multiplied that f theta by sin n theta d theta. So, first value, first term of this, that will be modified by a0 sin n theta d theta. And here that whole this expression that will be multiplied by sin n theta d theta, and this will be multiplied by sin n theta d theta. Now you will see this is basically the sin ultimately for one value, so that should be equals to sin square n theta. So sin square n theta, what we will get from that general formula, that sin square n theta, here you see sin square n theta, what is the integration value? That is the pi. Okay. So in this case, if you take integration of this, so ultimately you will be get that integration value is equals to an into pi an. Or in other cases, that already we found that integration of sin n theta d theta is basically equals to 0, and integration of cos and sin term, that is equals to 0 from the general formula. Already we see that. Sorry. In that general formula, if these two terms are different, sine and cosine, will be get that value is equals to 0. So that concept basically we applied here for this case. Cos and sine, that term is equal to 0. So these two term is equals to 0. Only this term present, that is pi into an, which is equals to again pi into an, which is equals to alpha alpha plus 2 pi f theta sine n theta d theta. Now if you shift this, any question, any confusion from your side?
হ্যাঁ স্যার ঠিক আছে।
ঠিক আছে?
হ্যাঁ স্যার।
Okay. Now you see, ultimately you'll be get that formula of an is equals to 1 by pi alpha to alpha plus 2 pi f theta sine n theta d theta. Okay. Similarly, for finding, now what is our target? Our target is to find out bn. So again we have to multiply this general formula f theta with cos n theta d theta. Okay, in both the side you have to multiply f theta by cos n theta d theta. So if you multiply f theta by cos n theta d theta, now every term in the right hand side they are modified. So that side is a0 cos n theta d theta. This will be multiplied with the cos n theta d theta, and this will be multiplied cos n theta. So now you see, in this case, only in this case, that will be act as a cos square n theta. So only for this case, that should be that integration of this is basically bn pi. In this case, these two terms are mismatched, that is the sine and cosine. So that integration value is equals to 0. And already we see that integration of cos n theta d theta also equals to 0. So first two term of this integration is equals to 0, and last term is equals to pi into bn. So now again, if you rearrange that equations, that we will found that bn is equals to 1 by pi alpha to alpha plus 2 pi f theta cos n theta d theta. Okay. Most of the cases you have to apply this theory because you need not required to derive this formula. Already you have to remember this formula, and you have to find out or by with the help of these three equations we have to solve that different problem. Okay. Up to these discussions, any doubt? Any doubt?
স্যার এত ফর্মুলা মনে রাখবো কি করে?
But you have to remember the formula. This formula only you have to remember this formula a0, an and bn, but this general formula of the integrations you have to remember. Otherwise, for the solution of this type of problem, it will be difficult if you do not remember this formula. So frequently you have to write this.
স্যার একটা কোশ্চেন ছিল, স্যার আমি একটু পরে জয়েন করছি, একটু কাজে ব্যস্ত হয়ে পড়েছিলাম স্যার। আমায় একটু বলবেন যে এটা কোন চ্যাপ্টার, বা আমি কিছু বুঝতে পারছি না।
এটা হচ্ছে we want to find out that what are the component present in non-sinusoidal waveform. Basically you can say this is the applications of Fourier series to find out what are the component present in the non-sinusoidal waveform. Most of the cases you will find out that most of the applications, this is basically the non-sinusoidal waveform. It may be the output of the generator, or it may be the transformer current, or it may be the any load current. They are basically in the non-sinusoidal nature. So our object is to find out what are the component present in non-sinusoidal nature. That most of the cases you will be see that non-sinusoidal components are basically the combinations of sine component but having different frequency. So they are basically represented by this formula, by these expressions, that f theta is equals to a0 plus a1 sin theta b1 cos theta a2 sin 2 theta, in that way. Means most of the cases they are basically the combinations of sinusoidal component of different frequency, but they are practically their nature in non-sinusoidal. What is our target? Our target is to find out A0, A1, A0, AN and BN value. So by using this formula, formula of A0, AN and BN, we have to find out that different coefficient. Already I showed that how to calculate or how these equations will become from the basic function, a basic integration. Okay, but for the solution of this type of problem, you have to remember these three equations. Okay, and this is the initially that previous equation based on the limit alpha to twice pi plus alpha, but some of the cases that waveform or analysis will be starting from the alpha equals to 0. So for that case, if you put that alpha is equals to 0, so that equations will be look like this. That previous equation and that equation, they are more or less similar, only the difference is in integration, but difference interval of this is equals to twice pi. Okay. Now again, if you change the limit from 0 to twice pi to, now here you see that limit is changes from minus pi to pi, but again the difference interval is, again this is equals to twice pi. Only that maybe instead of your analysis starting from 0 to twice pi, instead of this is starting from 0 to twice pi, it may be starting from minus pi to pi. These three equations are similar, only difference is in integration. Only difference is in this interval, integration limit. Okay. Now you have to think about that, say what I mean to say, that you have to a clear concept about that odd or even periodic waveform, odd or even periodic functions. Now what is the meaning of odd function and what is the meaning of even function? So just I want to show, say suppose if you write fx, say fx is equals to x. Okay. Now if you put x is equals to minus x, so that should be equals to what? Minus x, or we can write that is equals to minus fx. Is it clear whatever I written here? Any this is clear to you? Or if I write fx equals to x, okay, now if I put instead of x f of minus x, so that should be definitely that should be equals to minus x. Now I can replace that x value by fx value. So ultimately we want to show you that f of minus x is equals to minus fx. It is clear?
sir, ঠিক আছে.
Now if a particular function will be behave like this, this function is basically called the odd function. Okay, so in case of generally we'll see that sine theta, tan theta, sine theta, tan theta, this function are the odd function. Say suppose if f theta is equals to sine theta, so for that case if you put that f minus theta, so f minus theta is basically minus of sine theta. So if any function will be behave like this, by the general concept is this: if any function is like that f of minus theta is equals to minus f theta, or like this f of minus x is equals to minus fx, so we can say this function is basically a odd function, and generally sine tan theta they are basically odd function. And what we'll find that, and by visual inspection you can easily identify whether the function is a odd function or not if the waveform of this function or the nature of this function is symmetrical about the origin. Symmetrical about the origin means like this. Say if you consider a sine waveform, so that waveform is like this. So if you find that with respect to this origin, these functions are symmetrical, means if you consider this side or that side, with respect to the origin, these functions are, or you can easily identify from the visual inspection that a function is a odd or not. If they are symmetrical about its origin, then this function is odd function. Now what is the even function? Even function is basically if they holds the relations f of minus theta is equals to f theta. So for that case, this function is basically called the even function. And generally cos theta, sec theta, all of you know that if you consider that f theta is equals to cos theta, now if you put f of minus theta, if all of you know that cos of minus theta is equals to what? Cos of minus theta is equals to cos theta. So if f of and cos theta is equals to what? Again, this cos theta is equals to f of theta. Okay. So if a particular function holds this relation f of minus theta is equals to f theta, just like a cos theta, sec theta, this is the example of a even function. And by visual inspection also you can identify a function is even function when this function is symmetrical about its y-axis. Okay, just next slide I'll show you that graphically this function is basically a even function because with respect to this y-axis, these two sides are identical. So by visual inspection, we can say this function is even function. But with respect to the origin, these functions are symmetrical. With respect to this origin, these waveforms are symmetrical. So we can say this function is a odd function. By using the equations, f of minus theta is equals to f theta, or by graphical informations, if a particular waveform is identical about its own axis, so we can say this is an even function. And in case of odd function, if f of minus theta is equals to minus f theta mathematically, or from visually from the graphical information there, if the function is symmetrical about its origin, so we can say this is a odd function. So that concept is frequently required because we can easily verify whether our calculations, numerical solutions, that will be depends on or even function and odd function, some of the coefficients are 0. So if you identify that is a function even or odd, you have to find out mathematically all the coefficients. But if the function is even, sum of the term is 0. If the function is odd, sum of the value is 0. So just I want to show you the derivations of different coefficient a0, an and bn for even function and odd function with the help of these three general formula of a0, an and bn. Just you see, if a function is an odd function, even function is an odd function, so for that case, if you take integration f theta d theta within the interval minus pi to pi, so ultimately you will be get that integration value is twice of 0 to pi f theta d theta. Sorry, f theta is odd function, so for that case minus pi to pi, that integration value is equals to 0, because already you know, for in case of odd function f of minus theta is equals to minus f theta. But if it is an even function, for that case f of minus theta is equals to f theta. So for that case you will be found that integration of this function minus f pi to pi, that is no longer this value is equals to 0, that should be double of this 2 to 0 to pi f theta d theta. Okay. Now with the help of this formula, now we are applying that concept of odd function for finding a0, an and bn. Now if f theta is odd, whatever we studied from the previous slide, if f theta is odd, so what is the integration value? Integration value is equals to 0. Now here our consideration is that f theta is an odd function. So for that case, integration minus pi to pi f theta d theta, that is basically equals to 0. Okay. So this is the thing you have to remember. If a particular function is an odd function, so for that case, DC component or the A0 component is always equals to 0. Okay. Now we want to find out that an. What is the formula of an? Formula of an is 1 by pi minus pi to pi f theta sine n theta d theta. Okay. Now if f theta is an odd function, sine theta also an odd function. All of you know that already we mentioned here that sine theta is an odd function. So now f theta we consider in these derivations, f theta is odd function, sine n theta is odd function. All of you know that if the two functions are odd, their product should be a even function. Now f theta sine theta, here that will be act as a even function. So for even function, what we will get? Integrations of even function is basically 2 times 0 to pi f theta d theta. So by using this concept, we can write 1 by pi minus 2 pi f theta sine n theta. This is basically a even function f theta sine n theta d theta. So for that case, this is 2 times of 0 to pi f theta d sine n theta d theta. That is ultimate formula is 2 by pi 0 to pi f theta sine n theta d theta. Okay. So we are applying this formula. If a function odd, that integration 0. If a function is even, that integration value is 2 times 0 to pi f theta d theta. Now for finding bn, f theta is what? We consider that as a odd. What is cos n theta d theta? Cos n theta d theta is basically even. So what is the product of this? Product of this even into odd is basically a odd function. Now already in this formula, we will see if f theta is an odd function, their integration is definitely equals to 0. So here in this case, this is the product of odd into even. So that is basically act as a odd function. That is why that integration value is equals to 0. Okay. So whatever things you have to remember, if a particular function is a odd function, so for that case, only that an, that coefficient is present, means you can say an odd function can be represented by a set of sinusoidal but having sine terms, only that is composed of a different waveform having sinusoidal term. So if f theta is odd, its Fourier expansion contains only sine terms. And for your knowledge, that a0 and bn, these two value not equals to 0, that a0 and bn, these two value is equals to 0. So you have to keep in mind, or you have to remember that for odd function, you have to find out, or by mathematical calculations, if you do not know whether the function is odd or even, but if you find out the a0, an and bn, so ultimately you'll be get that for odd function this two term is 0, only this an value is non-zero. Okay. Now we want to apply that concept in case of, if here our consideration is that f theta is an odd function. Now we want to apply this concept for even function. So if f theta is an even function, so from the general formula, f theta d theta is twice of 0 to pi f theta d theta, that is This is 2 by twice by pi. That is ultimately will be get this value. Means if f theta is even function, a0 has definite value. Okay, and f theta is even, but sine theta, n theta is odd. Their product is odd. That is why this integration is 0. And f theta is even, cos n theta is even. So ultimately their product is even. So we'll be get some definite value. So what is our conclusion is that in case of even function, these two terms are present, a0 and bn, all the sine terms are 0. So this is our, hence in a periodic function is even, its Fourier expansion contains only cosine term and the constant term. Okay, so this is the up to the discussions, and based on that we can say a particular waveform is consist of a set of sinusoidal waveform. That sinusoidal waveform are basically called, except one that is called the fundamental, and and basically the multiples of the fundamental are basically called the harmonics. So frequently you have to see the term in the different study, that what is the fundamental component and what is the harmonics component. And all of you know what is our power frequency. Power frequency is basically 50 hertz. So 50 hertz is basically known as the fundamental component in a particular power waveform. But all the other term, that is the multiple of 50, that is 100, 150, say 200, 350, these are basically called the harmonics of the fundamental component, this 50. And when this multiples are even value, they are basically called the even harmonics. And when these are the odd value, they are basically called the odd harmonics. So here it is written, as discussed above, complex non-sinusoidal waveform can be represented by the superposition of sinusoidal wave of different frequency, and it is basically consist of constant value or a DC component, that is basically denoted by A0, a fundamental wave which has lowest frequency, that is f. It may be 50 hertz, it may be 10 hertz, whatever the lowest frequency, that is basically called the fundamental wave. And all the other multiples of the fundamental frequency, they are basically called the harmonics, that is 2f, 3f, 4f, etc. And that odd multiples of the fundamental, they are basically called the odd harmonics. And even multiples of the fundamental, they are basically called the even harmonic. So up to these discussions, always our target is to for analysis the non-sinusoidal waveform, and non-sinusoidal waveform is basically the combination of the three different component. One is the DC component, and one is called fundamental component, and all the other components are the multiples of the fundamental. Okay, up to this discussions, any queries? But you have to keep in mind, you have to remember this all the formulas, and these are the what I can say, this is much more general formula, but you have to remember. Okay, so you have to practice more so that easily you can remember this equation. These are the very simple integrations, just you have to if you practice more, so that is I think it is not a very difficult mathematics formula. If you practice more, then it will be easier. Okay, so up to these discussions, if you have any questions, you can ask me, otherwise I can go to the one numerical problem. Today I want to show you that how we will apply these three basic formula for finding that coefficient for a particular waveform. Why I will confine to only restricted to one problem, because this is the thing you need to learn first from your class note, and again after puja vacations we will discuss a different problem with the help of these three formulas. Okay. Okay.
Okay, sir.
Now you see this waveform. This is basically called the sawtooth waveform. Now, what is the type of this waveform? By visually you can see this waveform. If you extend this waveform in this side, this waveform is identical about its origin. So this is basically an odd function. Okay, whatever I mention in case of odd function, this is basically the odd function is basically symmetrical about its origin. So sawtooth waveform is basically the symmetrical about its origins. Now, in most of the cases, you will face this type of waveform only. That magnitude is provided, that is varies from minus a to a, and this is the time interval. Sometimes they will provide that function value, and but most of the cases you have to find out what is the general expressions of these functions. Okay, so most of the cases you will be face that waveform is given. You have to find out what is the general expressions of this waveform. So this is very simple. In 0, you'll see in 0 that value is minus a. So that value should be present. Minus a. And what is the slope of this? If you find out the slope of this is a straight line. Slope of this straight line is a by pi, and which is varies. This is the variable here is that theta. So this is basically called the slope. Sorry, this is basically called the slope of this straight line. And minus, why I consider this minus a? That minus a is basically the initial value at equals to 0. Now, in our hand, that expression of f theta. Now we have expression of f theta. Now, with the help of the formula of a0, a and bn, we have to find out what is the coefficient of a0, a and bn with respect to this function f theta. Now you see, already we defined that if a particular function is a odd function, that integration value is equals to 0. But mathematically, if you put that this is basically the function value, that is the f theta. Now, if you integrate this f theta with respect to theta, so ultimately, what is this? A by pi, what is the integration of this? Integration of this is basically theta square. Theta integration is basically theta square by 2. So that is a theta square by 2 pi. And what is the integration of the constant? Integration of the constant is basically theta. Now, if you replace the value of 0 and 2 pi, that is as a limit, so ultimately you will get that a0 value is equals to 0. Mathematically, we found that a0 value is 0. Also, the concept of odd function, we can write that a0 value is equals to 0 also. Okay. Now we want to find out a. Similar, what is the general expressions of an? If you first you have to write that general formula 1 by 2 pi. So 1 by 2 pi 0 to 2 pi f theta sine n theta d theta. So this is basically the general expression. Now we are replacing this f theta with the help of the function value a theta by pi minus 1. Now similarly, if you integrate this, that is if you take a common, then ultimately this is the two superposition of two integration, that theta sine n theta d theta and sine n theta d theta. And from the general formula, you know that theta sine n theta d theta is basically what? Theta into sine n theta. Again, there are two terms are present. Sorry, u into b. These two terms, if you integrate that, ultimately you will get these two terms. and sine n theta d theta, that general formula is cos n theta by n. Now again, after integrations, you have to put the limit 0 to 2 pi, and ultimately you will be get that an value is equals to minus 2a by pi a. So this is the formula. Also, if you remember that odd function an value will get an value is a non-zero value. So according to that concept, also we got that an value is equals to minus 2a by pi. But from the general concept that what is the bn value? Bn value is equals to 0. But mathematically you have to find out that. What is the general formula of bn? That general formula of bn, you have to write frequently this formula. Otherwise, it is very difficult to remember. 0 to 2 pi f theta cos n theta d theta. So this is the general formula. So here we are replacing f theta value is this, and ultimately if you find out that integrations, and after that if you put the value, so ultimately you will be get that bn value 0. If you remember this case, in case of the odd function, whatever we mentioned in case of odd function, just you see, in case of odd functions, only that an term is present, bn term also 0. So in case of periodic function f theta is odd, its Fourier expansion contain only sine term. So as per the knowledge we got from that previous discussions, that a0 is 0 value, an having some definite value, that is minus 2a by pi n, and bn value is equals to 0. So ultimately that f theta is basically composed of only that component having sine term, and according to that formula, that is minus 2a by pi n, you have to write that when n equals to 1, that value is equals to minus 2a by pi into sine theta. So that is first equation is minus 2a by pi sine theta. So if you put here n equals to 2, so that should be equals to a by. So in that way, you have to represent that expression of f theta. Means a particular sawtooth waveform can be represented by a set of sinusoidal component, and that sine component is basically consist only the sine term. Okay, so this is the discussions respect to the first numerical problem. If you have any difficulty in these solutions, any difficulty or any doubt up to this discussion? Any doubt?